The future of sustainable energy. How fusion power could save our planet. Imagine a future where our planet is no longer dependent on fossil fuels. A future where energy is not just abundant, but clean, safe, and limitless. A future where the power that fuels our homes, our vehicles, our Industry 7, our space exploration comes from the same force that powers the sun. This isn't just a dream, this is the promise of fusion energy. Welcome to a journey into the heart of one of humanity's greatest scientific frontiers, the future of sustainable energy and the awe-inspiring potential of fusion power. The global energy crisis. We are at a critical turning point. Our dependence on fossil fuel coal, oil, and natural gas has powered human progress for over a century. But it has come at a tremendous cost. Rising global temperatures, severe air and water pollution, depleting natural resources, escalating geopolitical tensions over energy. According to the International Energy Agency, global energy demand is expected to increase by more than 25% by 2040. Yet, fossil fuel reserves are dwindling. Our planet is warming at an alarming rate. Extreme weather events are intensifying. Climate refugees are becoming a reality. Clearly, something has to change. Renewables like solar, wind, and hydro are stepping in, but they're not enough on their own. We need something more, something powerful, reliable, and sustainable. That's where fusion comes in. What is fusion energy? Fusion is the energy of the universe. It's the process that powers every star, including our sun. At its core, fusion involves combining two light atomic nuclei, usually isotopes of hydrogen, into a single heavier nucleus. This reaction releases a tremendous amount of energy. Here's why fusion is so promising. It's clean. Fusion produces no greenhouse gases. It's safe. Unlike nuclear fission, fusion doesn't produce long-lived radioactive waste. It's abundant. The fuel for fusion, deuterium and tritium, can be extracted from water and lithium. It's powerful. A single cup of fusion fuel could potentially power an entire city for a day. But while the science is sound, turning fusion into a practical energy source has proven to be one of the greatest engineering challenges in history. The challenges of creating a star on Earth. To achieve fusion, we must replicate the conditions at the core of the sun, millions of degrees Celsius, and extreme pressure. This means heating hydrogen fuel to temperatures over 100 million degrees, keeping that hot plasma stable, containing it without it touching anything, because nothing can withstand that heat. This is where technologies like magnetic confinement and inertial confinement come into play. Magnetic confinement, used in reactors like tokamaks, uses powerful magnetic fields to trap and control the plasma. Projects like ITER, International Thermonuclear Experimental Reactor, are leading the way. Located in southern France and backed by 35 nations, ITER is the world's largest and most ambitious fusion experiment. It aims to demonstrate the feasibility of fusion energy on a commercial scale, and the progress is promising. Breakthroughs and innovations. In recent years, several breakthroughs have brought us closer than ever to sustained fusion. In 2021, researchers at the National Ignition Facility in the US achieved a record energy output from a fusion reaction. ITER's massive reactor is nearing completion, with its first plasma expected within the next few years. Private companies like Helion, Commonwealth Fusion Systems and TAE Technologies are attracting billions in investment, racing to commercialize fusion even faster. Artificial intelligence, advanced materials, and superconducting magnets are accelerating the pace of innovation. Fusion is no longer a pipe dream, it's a growing reality. The impact on humanity. So what happens when fusion becomes a reality? The implications are vast. Unlimited clean energy means we can decarbonize transportation, industry, and even agriculture. Stable energy prices could reduce global economic inequality. Energy independence could end wars over oil and gas. Clean air and climate restoration would improve global health. Fusion could power everything from electric grids to desalination plants turning seawater into drinking water. It could charge electric vehicles in seconds. It could make global food production more efficient. And most exciting of all, it could enable space colonization. Fusion-powered spacecraft could travel to Mars and beyond in a fraction of the time it takes today. The road ahead still, challenges remain. We need continued international collaboration, massive investment in research, public support, and policy frameworks that promote innovation. But the momentum is building. What was once a distant hope is now within reach. Fusion is the energy of tomorrow, but the work must be done today. Fusion represents more than just a scientific breakthrough. It represents human potential. Our ability to harness the power of the stars, to solve global crises, to build a future not based on fear or scarcity, but on possibility. So the next time someone says the future looks dark, remind them we're building suns on Earth. And with enough determination, enough collaboration, and enough hope, we just might light up the entire world. For more videos like this, subscribe our channel Wiki Story. Thanks.